All right, now I'm going to have a reaction from our debaters in a little bit, but we've listened to them for 2.5 hours already, and so I want to continue before we get to it. I want to get to the crux of the debate in at least one specific area, all right? And that's your statement that the light travel time argument was particularly strong. Now, this came up in the debate, okay? So if folks have watched the first 2.5 hours, they've heard this. Dr. Faulkner brought this up himself, and he said, if the world is 6,000 years old, then how in the world can we see things from 8 or 10 billion light years away from us? Okay? He said the Andromeda galaxy, the closest galaxy to us, is approximately 2 million light years away from us. Does light from galaxies billions of light years away really take billions of years to travel to our telescopes? If it does, then you can't escape the conclusion that the universe is 14 billion years old, unless you speculate something radically different happened to time or to the light phenomena. And Danny brought up 3 conclusions, possibilities that the young Earth, young universe folks suggest. Number 1, God created the light in transit, some kind of appearance of age arrangement, that God miraculously brought the universe into existence with this appearance of age, creating the light in a mature form at some point. All right. Number 2, that the velocity of light was somehow different in the past than it is today, that light would have to travel 1 million times faster in the past than it does today. Or that distant clocks in the universe ran 1 million times faster than they do here on Earth. All right. Now, I want to start with this. Let me hear your conclusions. What do you think about any of those 3 options? And why do you feel that light is such a key point here?
Well, Danny's comments and your summary really made the point. There's really good evidence, it's something we've made enormous progress on in recent decades, that we understand distances in the universe quite well out to a certain point. We have multiple interlocking ways. We can see stars of known kinds. With Hubble, we can see stars of known measurable kinds out to hundreds of millions of light years distance. Of course, everybody on the panel is a Christian. That was a stipulation. And the question isn't, did God have the ability to create light in transit with whatever properties he might have found appropriate? Going a little bit outside our brief here, the problem we all had with that idea isn't scientific, it's theological. If the heavens declare the glory of God, they are more than some sort of cosmic digital graphics. To take a concrete example, in 1987, we saw the light from the explosion of a star in one of our satellite galaxies, a large Magellanic Cloud, which, from multiple indicators, is about 150,000 light years away. This star, in its death throes, became temporarily bright enough to be seen as bright as the North Star for over 1/4 of the world's population. This was not a particularly subtle thing. If the universe was only thousands of years ago old, that star never existed. And that's just seems to be a real sticking point in this argument. You could postulate that the speed of light has changed, and in fact, cosmologists have wondered about changes in physical constants. You can't change the speed of light by itself without violating things we see. There are properties of atoms that change if you change the speed of light, because electrons interact with the nuclei by the electromagnetic force. Electromagnetism propagates at the speed of light. There are, for example, patterns of features in the spectra of distant astronomical objects that change if you change just the speed of light. And the constraints on that, it's an interesting enough question of physics that people have gone off probing this for quite independent reasons, are limits of parts in 10,000 and changes of the speed of light to very distant objects in the universe. If you wonder about clocks running at a different rate in the early universe, it arouses skepticism because it violates a principle of physics that the last few centuries have taught us to rely on, which is that the laws of physics will be measured to be the same no matter who's doing it and where. This is the whole point of relativity, was understanding how to do that transformation. And you can put together consistent models, but they amount to clocks run at different rates compared to all physical phenomena, which amounts to sort of relabeling time. And again, that's something that goes outside the range of things that would even have an imprint scientifically, because there's no measurement you can make.
It all comes down in large part to the cosmological principle, the idea that everything is homogeneous and isotropic, which is a fancy way of saying if you could get out and look down on the universe, you'd see it as all an even distribution of materials. And no matter where you are in the universe, as you look out, you see the same understandable universe. And that's one of the amazing things about astronomy, is we have the ability to slowly come to terms with what we see. And if what I see here on the planet Earth has to be consistent with what is seen by an observer on the other side of the universe looking back towards us, then, well, first of all, time has to allow the light to get to them. And it disturbs me a bit to think that, well, yes, God knows everything, that my light back towards that alien was also created somehow. And if time is running differently in both places, then how do you make time run strangely so that observers on the other side of the universe both have only experienced a short time, yet are able to see ancient time in the starlight? It's once you start figuring out, how do I make it so that my kindred on the other side of the universe can see and observe and experience physics that I experience, all of these arguments become that much harder to see as being possible.
All right, I'm going to brag about Don a little bit here, okay? He doesn't want me to do this, but I'm going to do it anyway. Dr. Don York is also the founding director of the Sloan Digital Sky Survey, collaborating with 30 institutions, 300 astronomers around the world that in 1998 began conducting the largest census ever taken of the sky. The Sloan Digital Sky Survey, if you don't know this, was created to systematically map 1/4 of the entire sky, producing a detailed image of it and determining the positions and absolute brightness of more than 100 million celestial objects. Also records the distances to 100,000 quasars and 1 million galaxies. Now, those might be old numbers, Don, but that's just to say I'm glad that you're here.